Today we are going to learn about mastering interactive plots with Matplotlib. We'll delve into the skills needed to transform static plots into dynamic, interactive visualizations using Matplotlib, enhancing your data analysis capabilities.
Welcome to our tutorial on mastering interactive plots with Matplotlib. In the world of data visualization, interactivity plays a crucial role in making complex data understandable and engaging. Unlike static plots, interactive visualizations allow users to explore data from different perspectives, interact with data points, and uncover deeper insights. Throughout this video, we will explore the powerful capabilities of Matplotlib in creating interactive plots. By the end, you'll be equipped with the knowledge and skills to transform your static plots into dynamic, interactive masterpieces that can significantly enhance your data analysis and storytelling capabilities. Before diving into creating interactive plots, it's essential to set up your environment properly. Start by ensuring you have Python installed, as well as the Matplotlib library. You can do this using pip, Python's package installer. Additionally, for enhanced interactivity, we'll use Jupyter Notebook, which provides an interactive interface for executing Python code. Install Jupyter Notebook via Anaconda or pip. Next, configure Matplotlib to use a backend that supports interactivity, such as TK-AG or NB-AG. This step is crucial because it determines how plots are rendered and interacted with. Once installed and configured, open Jupyter Notebook and create a new Python 3 notebook to test your setup by creating a simple static plot. This will ensure that your environment is prepared for the interactive features we'll explore in the following sections. mplcursors is a powerful library that allows you to add interactive tooltips and highlight data points in your plots. Begin by installing the mplcursors library using pip. Once installed, you can add interactive features to your existing plots with minimal code changes. For example, by importing mplcursors and using mplcursors.cursor, you can enable tooltips that display information about data points when hovered over. This is particularly useful for identifying specific data points in dense or complex plots. You can also customize the behavior of the cursor, such as changing the appearance of the tooltip or the information it displays. Here's a simple implementation. After creating a plot with Matplotlib, call mplcursors.cursor to activate tooltips. You can further customize the interaction by passing parameters to the cursor function, allowing for detailed control over how interactivity is presented to the user.
Widgets offer a fantastic way to introduce interactivity into your plots by allowing users to manipulate data and visualize changes in real time. The IP Widgets library provides a suite of interactive controls like sliders, buttons, and drop-down menus that can be linked to plot parameters. Start by installing IP Widgets through pip and importing it into your Jupyter Notebook. You can create a slider widget to adjust parameters such as the threshold of a plot or the number of displayed data points. Bind the slider to a function that updates the plot whenever the slider's value changes. This dynamic interaction enables users to explore different scenarios and observe immediate visual feedback. For instance, create a sine wave plot and use a slider to adjust the frequency of the wave. Each adjustment to the slider will result in an instant update to the plot, providing an intuitive understanding of how frequency affects the wave shape.
Event handling in Matplotlib allows your plots to respond to user interactions such as mouse clicks and key presses, thereby enhancing the interactivity of your visualizations. Understanding event handling involves capturing these interactions and defining responses that can update or modify the plot dynamically. Matplotlib provides event handling capabilities through its mpl_connect function, which you can use to bind specific events to callback functions. For example, you can create an event that listens for mouse clicks on a plot and displays the coordinates of the clicked point. Alternatively, bind a key press event that triggers a change in the plot's data. This level of interactivity engages users by allowing them to explore data from different angles and perform custom actions based on their interactions. To implement event handling, define a function that executes the desired actions, such as updating a plot, and use mpl_connect to associate this function with a specific event. Zoom and pan features are essential for navigating large datasets and focusing on specific regions of interest within a plot. Matplotlib's toolbar provides built-in support for these interactions, allowing users to seamlessly zoom into and pan across plots. By enabling these features, you provide users with the ability to explore data in greater detail and gain deeper insights. To activate zoom and pan, ensure your plot is displayed using an interactive backend such as TK-AG, which supports these interactions. Utilize the toolbar's zoom button to zoom into specific areas of the plot, and the pan button to move the view around. These features are particularly useful in time series data or geographical data visualizations where users need to focus on particular time frames or locations. By implementing zoom and pan, you enhance the user experience by offering intuitive navigation options that make data exploration more engaging and insightful.
Linking plots is a powerful technique for comparative analysis, allowing users to interact with multiple plots simultaneously. This is particularly useful when comparing different datasets or visualizing the same dataset across different dimensions. To create linked plots, you can use Matplotlib subplots to arrange multiple plots on a single figure and share axes between them. By synchronizing interactions, such as zooming or panning, across these plots, users can maintain consistency and gain insights from comparative viewpoints. For example, when analyzing sales data from different regions, you can create separate plots for each region and link them to share a common time axis. This enables users to observe trends across regions simultaneously, facilitating a comprehensive analysis. Implementing linked plots involves configuring subplots with shared axes and using event handlers to propagate interactions across plots, ensuring a coherent and interactive user experience.
Designing interactive plots requires a balance between functionality and user experience. Start by focusing on clarity and simplicity, ensuring that your plots convey information without overwhelming users with excessive elements. Prioritize the most critical data points and interactions, and avoid clutter by limiting the amount of information displayed at once. Additionally, ensure that your plots are intuitive and easy to navigate, providing clear instructions or tooltips where needed. Thoroughly test the interactivity of your plots across different devices and screen sizes to ensure a consistent user experience. Gather feedback from users to identify areas for improvement and iterate on your design based on this input. By adhering to these best practices, you can create interactive plots that are not only informative and engaging but also user-friendly and accessible, making data exploration an enjoyable and insightful experience.
In conclusion, mastering interactive plots with Matplotlib opens up a world of possibilities in data visualization. We've explored various techniques to transform static plots into interactive experiences, from setting up the environment and using the mplcursors library, to integrating widgets and implementing event handling. These skills not only enhance your data analysis capabilities but also empower you to create engaging visualizations that communicate insights effectively. Remember that interactivity is a powerful tool in making data analysis more intuitive and accessible. We encourage you to practice the techniques covered in this video and continue exploring the vast potential of interactive data visualization. Thank you for joining us on this journey to mastering interactive plots with Matplotlib.